Hello, everyone. Today we're going to deploy the AWS Nextflow Quick Start. This Quick Start deploys a genomics analysis environment on AWS using Nextflow to create and orchestrate analysis workflows and AWS Batch to run the workflow processes. Nextflow is an open source workflow framework and DSL for Linux. The tool enables you to create complex, data-intensive workflow pipeline scripts, and it simplifies the implementation and deployment of genomics analysis workflows in the cloud. The Quick Start is for teams or individuals who manage informatics infrastructure and genomic analysis for biotech companies. This Quick Start deploys Nextflow into the infrastructure that was developed or deployed by the Biotech Blueprint Quick Start. So essentially, this is sequentially a series of quick starts that you're going to deploy. If you want to use an existing VPC or create a new VPC, we have separate instructions to follow for deploying that genomics workflow on AWS. So with that, I will hand it over to Paul Underwood, who's a principal solutions architect and author of the Nextflow Quick Start. He's going to show us a step-by-step deployment guide on how to get the Quick Start up and running. So with that, over to you, Paul.
Thanks, Alexis. Hello, everyone. Today, we're going to be diving into Nextflow on AWS. For those of you who have deployed the Biotech Blueprint, you'll be able to take advantage of this. For those of you who have not, who aren't taking advantage of the Biotech Blueprint, you'll be able to take advantage of some of these pieces by following our AWS genomics reference architecture for Nextflow, which the Biotech Blueprint version is identical to. The main differences is that the Biotech Blueprint sort of makes a lot of the configurations around VPC and subnets and security groups and things of that nature a lot easier. And it also includes a example notebook environment that you can use to via SageMaker, that you can pull up a Jupyter Lab environment and submit jobs to Nextflow, to AWS Batch, and take advantage of those in the notebooking environment. The rough architecture for this, for those of you who deploy the Biotech Blueprint, this should look familiar. You'll have your public or your DMZ subnets, your application subnets, and these in your database subnets. These would have already been created for us inside by the Biotech Blueprint 1.0. The Quick Start creates a number of batch compute environments where future Nextflow jobs will run inside, and that SageMaker Jupyter Lab environment that I mentioned, that's sort of pre-configured to integrate with AWS Batch in the Nextflow containers that run inside them. And so with that, I'm going to pop over to the AWS console. Again, if one of the major features that the Biotech Blueprint deployed is the Biotech Blueprint Service Catalog. And so if you followed along in the first video for the Biotech Blueprint 1.0 deployment, you will have this similar environment here available to you. What you'll do is you just go to Services, go to the AWS Service Catalog console, and then you'll want to go to this Products tab here in the top left. If you don't see that, you need to give yourself permissions. And the way that you give permissions, just to kind of demonstrate that, is you'll click on this Portfolio under the Administration section. You'll choose the Biotech Blueprint Informatics Tools portfolio. Click on this User, Groups, and Roles, and then from here you can add individual users or IAM roles or groups of users. And that basically gives people the permission, or those individuals permission, to launch the products, which once they have those permissions by going to this product list, they'll see all the available tools that are currently available in the Biotech Blueprint Informatics Catalog. So today we're going to be launching Nextflow, so I'm going to go ahead and choose that. We're going to give this a name. I'm just going to call this Nextflow 0. We'll hit next, and then we'll get to the parameters section. Now, a lot of these parameters are going to be defaults for you. In this case, I'm going to supply but you need to supply a few that are required. And so, first thing that I'm going to do is create a bucket. And so I'm going to use an existing bucket for just in case you guys haven't gone through that experience before. So I'm going to create a new bucket for my Nextflow environment. And so I go to the S3 console, and you can have Nextflow you can have this quick start create a new bucket for you, but it's likely you'll already have a bucket created. So I'm just going to go through the process of creating one just to show you. And so we'll call it something simple. And that's all you need to do. Provide a name for it, accept the defaults, and that'll create a new bucket for you in that environment. So we'll put in our S3 bucket name that we just created. We're going to say this is a existing bucket. And this bucket, the purpose of this bucket is for staging, is a location for staging your Nextflow scripts as well as the results that may come, the outputs of your Nextflow scripts. And so that's what that bucket's for. So you may choose to use something that's existing, that's fine. Just make sure you set this existing bucket to true if that's the case. The Nextflow script folder prefix, if you want to leave it in the root directory, you can. Sometimes you may want to have this in your own maybe user-specific workflow directory or a shared one. That's really up to you, but this is where the Nextflow head node, when it runs, is going to look for the location of your scripts. And we'll go into that when we get to the notebook. The rest of this I can more or less just set as the default. There really isn't much more that you need to specify. Here you can optionally include the Jupyter Lab environment. In this case, we do want to include that. If you're just interested in standing up the batch components, you can set that to false. And then you have some VPC options. Again, you don't need to specify these because if you deploy the biotech blueprint, we set up the appropriate parameter store integrations. We know where to put your subnets, essentially, and so you don't need to supply any of that. This is where we're getting into your AWS batch configuration options. If you're just doing this for the first time and you're not familiar with batch, again, just leave these as the default. This is going to give you the lowest cost option. It's where if there's no jobs running, there's not going to be any compute running, and so there's no cost for your AWS batch environments to be up if there's no CPUs at the moment running. So we're going to leave these minimums to 0 at the moment. Again, if you have your own custom Nextflow image that you prefer to use, you can build your own. If you leave this blank, we're going to set up, the Quick Start will set up an AWS code build environment for you that builds a Nextflow container and checks it into our Elastic container repository. So just leave this blank unless you're particularly have a specific version of Nextflow or particular change you want to apply. And then finally, we'll just sort of blast along. And just another point on that, in the event that you do want to modify the Nextflow environment, it's almost always it's likely better to just modify the code build environment that gets created for you by this Quick Start, as it's really going to, it follows a lot of best practices in terms of building images on AWS, and it's probably just better to extend that than roll your own. So here we go. This is what it's going to look like while the Nextflow environment is being provisioned. You'll see that it's kind of in progress. In general, this takes about 7 minutes to deploy. But while this is going, I'll walk you through some of the pieces that it's creating for you. If you get impatient, you can actually Service Catalog uses CloudFormation under the covers here. And so you can see the Service Catalog environment starting to create the main pieces for us here. So this is that root stack. And now here, this is creating the necessary S3 buckets and S3 roles that are going to be associated with getting access to those buckets. The launch template is another really important aspect. And one of the major differences to the official Nextflow documentation is in that documentation, you bake AMIs, or the Amazon Machine Images. With AWS in our reference architecture, we use launch templates instead. And that launch template has a special treat baked into it where it actually auto-scales the EBS volume for the scratch space that your containers need over time. And so the way we're doing this is by taking advantage of better FS, we're able to dynamically monitor the status or the capacity of that volume, and then attach additional volumes as that's filling up in increasing increments. So 300 gigabytes at first, then 500 gigabytes after the fifth volume, and eventually up to terabytes in capacity. This is important from a cost-saving perspective because this way, by achieving the elasticity, you don't have to provision for peak all the time. And if you're ever launching hundreds of instances due to your Nextflow pipelines, that can add up. And so this dynamic storage that this launch template provides is a big cost saver. And from a Docker perspective, we're actually not only are we using BetterFS, but we're changing the Docker storage driver from device mapper to BetterFS, so that you don't have to modify anything on the actual containers that you run to take advantage of this essentially auto-scaling EBS capacity. By default, all the I/O that those disks use will hit that sort of logical BetterFS volume. So it saves a lot and means that you don't have to think about it when you're building or taking advantage of containers. And then finally, we're seeing some IAM permissions getting created here. This is the necessary IAM permissions for batch to communicate with S3 and other locations. And then finally, this batch stack is we'll jump into next. And we'll actually pop into batch while this is creating. So let's just see where we're at. Yeah, so we're going to have our environments creating now. So I'm going to pop into the batch console and we'll walk through what is getting created for us right now. So AWS Batch has really 4 primitives that you need to think of. It's not more complicated than that. What I like to do is start at the baseline. These compute environment is at the compute environment level. So you'll see I have 2 compute environments, and these were created by the Quick Start. One compute environment is based on our Spot provisioning model. For those of you who don't know, Spot is where we have excess capacity in our AWS data centers. We offer that at a discount at the risk of your instance potentially randomly being interrupted due to change in demand on the traditional on-demand market. The savings can be significant, sometimes up to 90%. And so really at large scale, almost all major, ideally almost all large scale processing that you do will be on Spot instances. And one of the beauties of batch is that you don't have to think about really when you're submitting your jobs to take advantage of Spot or not. As long as you're targeting the compute environment when you submit your job for the Spot, it will run, that compute will run on the Spot environment. You really don't have to think about it beyond that. The on-demand is your conventional on-demand, sort of just typical sticker prices that you would see without the risk of interruption, obviously. And another thing I want to point out here is instance types optimal here. And this is a big value proposition of AWS Batch. I'm not having to specify M4 5x, 10x large, or M4x large, or R5 2x large. I'm not lost in the instance family. What Batch does is when I submit jobs to Batch, it does the bin packing to figure out the optimal mix of instances to schedule your jobs to run on. And so instead of me having to pick instance sizes, Batch is doing that bin packing for you in a much more efficient way. And finally, there's another feature of compute environments these days called allocation strategy. And you can pick a Spot optimized allocation strategy that will dynamically choose the Spot instances that are least likely to get interrupted when picking instances for your jobs to run on. But again, when you're submitting the job, you just submit the job and a Batch handles all of that back-end bin packing for you. So at the so I have this compute sort of environment at the base level. At the application level, I submit jobs to queues. And if we look at the default job queue here, the first compute environment we prioritize is the spot environment. So the idea being that you want the majority of your jobs to be running in spot. For the high priority jobs that need to run right now and can't be interrupted, you submit those jobs to the high priority queue. And you'll see that the high priority queue prioritizes the on-demand environment. So finally, we have our job definitions. You'll see there's this single job definition Nextflow right here. And this one is responsible for, is essentially the head node. And we'll talk a little bit more about that when we get to the example notebook. But this head node is what kicks off. You submit this Nextflow job directly to batch using this job definition. And then based on your Nextflow script, Nextflow is going to create additional job definitions for you under the covers, right? And that really depends on how you define, which containers you want to use and, whether they're public or private, but Nextflow for the most part is going to be responsible for creating additional job definitions. So you really shouldn't need to be in here creating job definitions unless you're customizing something particularly. And then finally, you have jobs. And then when you submit a generic job to batch, just as a for example, you would give it a name, you would select the job definition here. In this case, if I wanted to run a Nextflow job, I could kick off a Nextflow job by choosing the job definition. For the most part, though, you won't be using this AWS submit job batch interface like this. You'll be using command line or notebooks, and we'll show you, what the notebook version of that looks like here in a second. But just as a, for example, you can kind of see here some of the detail that you can specify. Here I can specify the queue I want my job to run on. Do I want it to run on the standard spot, or if I want to run the high priority queue, I can. Batch has a underlying job attempts feature to it, and so if a job fails, for example, let's say because the spot instance got interrupted, if you have this number set to 2 when you submit the job, it'll actually retry that job for you. There's nothing else you need to do. It'll just retry that same job a second time. If the underlying host fails for some physical reason in the data center somewhere, again, batch is going to notice that and then rerun a job again for you if that occurs. Here you can specify, the precise details of the command that you want to run, and oftentimes if you're submitting thousands of jobs, this is where you're putting in, effectively the parameters to your Nextflow script. But this is really perhaps maybe the most important part. You'll see here when you submit a job, you specify the CPU and memory of the job that it needs. And this is what batch uses to do that bin packing I was talking about. So if I had 100 jobs that needed 2 cores and 1 gig of memory, and then 50 jobs that needed 32 gigs of memory and 8 cores, I don't have to think about it beyond just submitting the job. And in Nextflow scripting, equivalent, when I specify core, CPU and memory, those parameters get passed to batch effectively using override kind of to these parameters. And so in your actual Nextflow scripts, you specify memory and CPU requirements, and that translates to effectively submitting a job to batch with virtual CPUs and memories. And Nextflow handles that all for you. You just specify it in your Nextflow script, which is really convenient because, again, you're in process in your script, in your Nextflow script, able to define that configuration, or in a Nextflow config file. You don't have to think about it at the API level. So if I wanted to, I could submit that job, and that would kick it off. So let's go back and look at CloudFormation and see if we're all done. It looks like we sure are. And so what I want to do here is look at, we're going to go over to SageMaker, and we're going to pull up the notebook environment that our blueprint created for us. So if I go to notebook instances here on the left, you'll see here I've got, if I had put in my name, I would say Paul Nextflow Genomics here. But to open it up, I click the Open Jupyter Lab. And this is going to open our managed Jupyter environment. And this one is set up to the role that's associated with this IAM host, or with this Jupyter Lab machine. Already has all the necessary IAM permissions as it was set up by the blueprint. But this NF Core RNA-seq example is a RNA-seq example that comes off the Nextflow core, from the Nextflow core group. And here's you'll see some cells down here before. Again, because this was part of the biotech blueprint deployment, we, were able to you'll see some of these values have been pre-populated. Again, just the convenience to folks who are deploying it, so they don't have to go hunting around for all these parameters. But to kind of put you in place in the context of this architecture and explain what's happening here, we're here right now in this SageMaker notebook environment. We want to submit a Nextflow job. In this case, again, we're using this Nextflow core RNA-seq example here that many of you may have tried to use in the past. And it is, so that sort of lives here in this sort of folder structure. I might be in here developing this inside the notebook and working on it directly here. And what I'm going to do is I'm going to first sync my local sort of Nextflow script file into our little staging directory. And then I'm going to submit a job to that sort of Nextflow head node. And I'm using the AWS batch APIs to just sort of submit that single job. And that's actually going to execute or kick off that Nextflow binary. The Nextflow run command runs inside of here. Now, depending on your script, that Nextflow run command might spawn one process. It might spawn tens of thousands of processes. But Nextflow is going to start, this head node here is configured to communicate with batch and will submit, your thousands of jobs or tens of jobs or ones of jobs to batch for you. So you submit one API call, and that one API call might kick off, potentially, thousands of different containers executing concurrently. All of these containers are going to be writing their standard out and standard error to CloudWatch. And so you can go to CloudWatch and batch and look at those jobs running in place, or you'll see here we've got a little convenient tail function that lets us sort of monitor this head node's CloudWatch logs right here from the notebook. So to kind of click us through the notebook here, we're going to kind of instantiate, some just basic parameters around where we're going to stage our Nextflow script. Again, this is like our, our RNA-seq example here, where we're going to put those, where we want to, what folder we want to stash these things in, what job queue we want to run this on. In this case, we're just doing development, so we're going to deploy it to the default queue. And then we're going to run that Nextflow head node job that we looked at, that job definition that we looked at earlier. So now this next cell just does a simple AWS S3 command. And so this is essentially taking this directory here that you see on the left and syncing that into our S3 bucket where our scripts lie. So essentially that last cell did this arrow right here. So when the head node job gets submitted, it's the first thing it does is look in that source directory for some scripts, and then what it finds, it runs. And you'll see here when we look at the actual batch job, so this is the AWS batch submit job API, nothing fancy. We define the head node job definition, right, which was Nextflow up here. We're giving it a name. This could be anything. We're just going to call it Nextflow head node test, for example. The job queue, we pulled that from up here. We're just saying run it on the default one. And then we're submitting the command. And so here I'm specifying an S3 prefixed path to where we copied our files, right, to this bucket. This could also be to a Nextflow GitHub URL, or if there's a Nextflow pipeline in GitHub, this would work with this. This parameter effectively gets passed to the Nextflow run binary, and so depending on what that Nextflow run command typically supports is what this first parameter ties to. And then you'll see these other parameters. This is just a string, an array of strings, and AWS Batch adds a space in between each one of the strings that you supply. And so just like you would in your Nextflow run command, say Nextflow run your script, and then pass parameters to it, delimited by spaces. That's how you would specify that here, right? And so that's the equivalent, and that's how that gets translated. So if I run the job, we'll get a job ID back here. And our job ID comes back instantly because this is, the job gets submitted and it's starting now to execute in batch. And we'll go take a look at that here in a second. But I've got a little helper function here that just tails the CloudWatch logs for the head node. And so we'll see that output start to show up here once the environment kicks off. So again, our little Nextflow head node is warming up. It's going to start processing it's going to pull down this these pair-ended files from the 1,000 genomes and kick off the RNA-seq process, and all that CloudWatch log will follow there. So let's take a look at in batch. What's happening now. In our dashboard, you'll see here our job queue. We've got our one runnable job, and our one runnable job is essentially waiting for its host to come online so it can start executing. And when this head node job runs, it's going to sort of read the input channels that you've defined in Nextflow, in this case, the RNA-seq pipeline, and it'll start submitting any necessary, start kicking off any processes that are ready to go. So if I look at, let's look at where does this sort of runnable stuff really live under the cover. So let's first take a look at AWS. So you'll notice here, if we look at our compute environments, if we pop over to AWS ECS, our Elastic Container Service, you can start to see a little bit under the covers of what's going on here. So you'll see there's actually 2 ECS clusters that have been created for us. And again, batch is what manage these clusters for you. You don't have to touch these things ever. Don't touch these things unless you're doing some troubleshooting. And again, try to keep that to a read-only capacity. But what batch does is it manages these ECS environments. And so when capacity comes in, it starts to submit jobs to, or starts to run tasks on these ECS environments. You can see that rubber hitting the road, so to speak, in your AWS console. So we should see here a spot worker already initializing, right? And so this spot worker is about to launch, and it's going to effectively join the compute environment in an AWS batch. Just to show you where another kind of look under the covers, because we're using Spot, you're going to see the Autoscaling Group effectively for the Spot compute environment to be managed by these Spot requests here. So if you're ever curious where these instances coming from, hey, my jobs are stuck and runnable, which is a common problem. Take a look here in the history. You'll see oftentimes maybe you're hitting a limit increase, or maybe there's a spot availability in an availability zone you're looking at. It can be hard to troubleshoot that directly from the batch environment. Coming here and kind of looking direct and seeing what's happening in terms of the auto-scaling instances coming on, what savings you're getting, like these are generally pretty handy. You can kind of see where it sort of looked at all these different instance types and decided, no, the M4 large is the best right now based on the spot price. And this is for your spot instances. For the compute environments that are using on demand, obviously those aren't spot, and so you'll see those under your conventional Autoscaling Group definitions here. And we don't have any jobs submitted yet, and so Batch hasn't actually created any Autoscaling groups yet because there's no capacity needs. But that's where it would appear if you were using the on-demand environment. So let's go back to Batch, and we'll take a look at our job. And you can see now that it's running, and it's been running a little bit because we've already got 4 jobs in the runnable state. So if I scroll down here, you can see our little tail function here is now kind of tailing that head node, and you know, you've got the typical NF core ASCII art, which I love. And then you can kind of see details about the job, and you see this is all essentially conventional Nextflow run output. And you can see it's kicking off a number of jobs at this point. You'll see that kind of the last update were these 4, and then we've got our 4 batch jobs kind of underway, and the rest are the rest to come. And just to give you a sense, if you wanted to look at a let's say an individual job's CloudWatch detail, you select that job by either finding it through the dashboard or where have you. And if you scroll down, you'll see a CloudWatch Logs option here. And if the job is finished, you'll see another entry a little bit higher. But this CloudWatch Log link will take you to the detail or the spot in CloudWatch where you have the latest Nextflow scripts. And you see it's ASCII art doesn't quite look as good here due to formatting, but you can get that same output here. And any child jobs or any job or processes that Nextflow starts, for example, you know, these 4 runnables, once they start to begin, you will, they individually will have, just as a for example, they'll eventually have a CloudWatch log output down here that you can see the output of as well. So that is sort of what submitting a job looks like through a notebook environment. Now, obviously, this is Python that we're using here. You could absolutely use the AWS CLI to submit jobs directly to AWS Batch. And you may even choose during development to run the Nextflow head node on your local machine and effectively call from Batch from your local machine to Batch. That's a totally viable option. You know, you'll eventually probably want to use and run that primary head node inside of Batch so that you can like close your laptop and get coffee and not worry about jobs getting closed down. But during development, it's a totally reasonable thing to think that you may want to run the Nextflow head node locally and use Batch as the executor. That's a totally other, valid development approach as well. Our reference architecture calls for submitting the head nodes to run on Batch because we believe that when you're doing an event-driven architecture in the future, that's what you'll be submitting jobs head nodes to Batch in this way that we're doing today. But if you have any questions about that, please don't hesitate to reach out to the Nextflow user groups or your AWS solution architect, and we'd be happy to help find you answers. One more thing that I wanted to point out is host access. These EC2 instances that launch, you'll notice that we don't specify any key pair. One of the ethos of the biotech blueprint is to avoid using key pairs when possible. You'll see the key pair is blank. So if you want to get host access onto these machines, you'll want to use AWS Systems Manager. Systems Manager available on your local command line interface or through this handy web interface. But if you go to Systems Manager and then go to Session Manager down here, choose the Start Session, you can select an instance where one of your jobs is running, and then select Start Session, and that's going to put you directly on the box of our running host. And so if I do, for example, I can get a list of the currently running containers. And this first one here, you can see it's running the Nextflow head node at the moment. You've got our image coming from our Elastic container repository that our code build process that I mentioned earlier is created for us. That private container is running right now, and it's been up 4 minutes. This ECS agent one is important to point out. This ECS agent is a key, is what allows the host to report statistics to AWS ECS as well as to batch. And so if you ever get a job that's stuck and running, or for some reason it seems like jobs aren't behaving or starting, or there's instances sticking around, take a look, get onto the host and see if this ECS agent is actually running. Sometimes if there's memory contention or an issue on the host, this agent may fail. If that's the case, you may want to revisit the specs and the instance sizes that you're using. But the easiest thing to do is just restart the ECS agent, and then those jobs should sort of fall out from being considered stuck, or the instances will fall out of the cluster as they'll be properly marked as unused. So just another little tip to consider. And again, this is available through your local CLI. You don't have to use the web interface for this, but Systems Manager is a handy feature that we turn on by default in the by deploying through the blueprint. And then finally, I just wanted to point out that launch template feature that we talked about earlier. You'll see here that there's a launch template definition, and this is, again, a distinct difference to how the official Nextflow documentation suggests that you use AMIs, which is something of a pain. Launch templates are really the right way to do this, and if you'll see that launch template defined for you, again, created by the blueprint, defined here under launch templates. You'll see a few here that are being used by the batch and compute environment as versions, but you can see here the script that we're using to actually install that EBS autoscaling solution and adjust Docker to use BetterFS instead of ECS or instead of the device mapper. All right, everybody. Thank you so much for your time today, looking through Nextflow on AWS. Hopefully this has been helpful. Again, don't hesitate to reach out to your AWS account team if you're looking for any support with this sort of thing. We're here to help. Thank you very much, guys. Appreciate it. Bye.